Hello friends, myself Dr. M.K. Goku, Department Mathematics, Government College Ajmer. In my earlier lecture, we discussed about the Lorentz transformations and finally derived a relation between two frames x dash and ct dash is equal to cos hyperbolic theta minus sin hyperbolic theta minus sin hyperbolic theta and cos hyperbolic theta and c x and c t x and c. This was the precise way to represent the Lorentz transformations equations. Lorentz transformation equation can be put in this format. Now, from this, using this representation, we can find the composition of relativistic composition of velocities. Means two frames, there are two frames which are moving this frame S dash moving along as this is frame as this is moving frame as this S of O dash as this is moving with relative velocity with v velocity, means this frame is moving with velocity v with respect to this frame. And the third one S double dash this third frame O double dash. S double dash is moving relative to this one is by V dash. V dash and V double dash say. V dash and V double dash say. Now, any event in these frames, this frame S dash is moving with respect to this one. This frame is moving with respect to this one, and we need to find the relation between S and S double dash. Means composition of velocities. We need to find composition of velocities from these three. So x dash upon x dash ct dash can be written as this. These are the quantities in first coordinate system, first frame with respect to first frame. X is the location of point C. This is the x. So location of the point at time t. At time t, we use this transformation. V is equal to c tan hyperbolic theta. If this frame is moving with respect to this velocity v, then v will be equal to c tan hyperbolic theta. Now, if this frame is moving with respect to this with the angles v dash or v dash, I can write here v dash, and v double dash will be equal to c tan hyperbolic 5. Tan hyperbolic 5. Then this relation between second and third will be given by x double dash. The coordinate of this event at this point is x in first coordinate system. In second coordinate system it is x dash, and third coordinate system, third frame with respect to third frame, its coordinate is x double dash. So x double dash and time with respect to first coordinate system, first frame is t, since with respect to second frame it is t dash, and with respect to third frame it is t double dash. So t double dash will be equal to, similarly, cos hyperbolic phi and minus sin hyperbolic phi minus sin hyperbolic phi and cos hyperbolic phi. And we are using Lorentzian transformation, therefore Lorentzian representation of this, we are using this representation of Lorentzian. So x dash and c t dash. Now x double dash, I can write x double dash c t double dash will be equal to cos hyperbolic phi minus sin hyperbolic phi and minus sin hyperbolic phi and sin hyperbolic phi and cos hyperbolic phi, and x dash and ct dash is nothing but this one, so I can write cos hyperbolic theta minus sin hyperbolic theta and minus sin hyperbolic theta and cos hyperbolic theta and x and ct. Now this will be equal to this multiplied by this will give us cos hyperbolic square phi cos hyperbolic square phi plus sin hyperbolic square phi, and this will give us cos hyperbolic theta plus phi, and again multiplying this by sin hyperbolic and sin hyperbolic this with this. So using the property of multiplication of matrices, I am using this cos hyperbolic theta plus phi minus sin hyperbolic theta plus phi and minus sin hyperbolic theta plus phi and cos hyperbolic theta plus phi, and this is x and c. Thus we can see that this is the relation between first frame and the third one. This is the relation between first frame and third one. If I use this, w is the velocity, combined velocity of this one. W is the velocity of s double dash relative to s. Means if I represent w as the velocity, relative velocity of s double dash with respect to s, then w will be equal to w will be equal to c tan hyperbolic theta plus phi. Then this will appear. This is the Lorentzian transformation of these three frames of this image from one frame to another to third one. So this I can write c tan hyperbolic theta plus tan hyperbolic phi upon 1 plus tan hyperbolic theta tan hyperbolic phi. Now this will give us v dash is equal to c tan hyperbolic theta. So c tan hyperbolic theta is v dash and c tan hyperbolic phi will be equal to v double dash upon 1 plus v dash and v double dash upon c square. V double dash upon c square. So this gives us the composition of velocity v dash and v double dash for this. This is the point. This is the frame moving with respect to this one with velocity w. W is the relative velocity of this frame with respect to the first one is given by this. So this is the composition of velocities, our relativistic composition of velocities. So the third frame, this has significant consequences. This result gives us insight about the velocities. Now, what happens? V double dash 1 plus v double dash upon c square gives us the consequences of this. If v dash, I can write if v dash is equal to mc, means this is your n, and v double dash is equal to nc, then it will be equal to mc plus nc upon 1 plus n upon c square will cancel out. So this is m plus n into c. M plus n into c. 1 upon. Now if analyzing this equation, what will we find? This equation along with this. If m is less than 1, then let us consider the simplest case that when m and n both are equal to 1. What happens? If n is, it means the second frame is moving with respect to first one with the velocity of light, and the third frame moving with respect to the second with the velocity of light, then what will this give? N is 1 plus 1 upon 1 plus 1, 2 cancel out, and w is equal to c. So if m is equal to 1, n is equal to 1, then w is nothing but the velocity of light. W moving with velocity of light. So if this frame is moving with respect to this one with velocity of light, this frame is also moving with respect to this with the velocity of light, then naturally this frame will move with respect to this one with velocity of light. This is all right. Now, the different thing. If n is less than 1, n is less than 1, both are less than 1. What happens? Means is less than 1, this is less than 1, and this term 1 plus mn. What's this? This term. If m and n both are less than 1, then what happens? This is less than 1, this is less than 1, and this is less than 1. Two terms multiplying by less than 1 are very small, and 1 plus means this is 1 less than, say, it is, let us take 0.9 and 0.9. So this will give 0.81. This will give us 0.81. And this is 0.9 and 0.9 minus 0.81. 0.81 divided by 1.81. Then what happens? This quantity is very small, and thus W is less than, this gives us W is less than C. So if both are less than 1, W is less than C. Means if this frame is moving less velocity to this velocity of light, and second frame moving with less velocity than velocity of light, then W is less than C. Again, if n is greater than 1, n is greater than 1, n is greater than 1, means, say, for example, both are taking as 2 and 3, 2 and 2, so 2 and 2, 4, and 2 into 2, 4 plus 5, 4 divided by will again be a quantity less than 1. So in this case, W is less than C. W is less than C. But in case one of them is greater than 1, M is greater than 1 and N is less than 1, 1 is greater than 1 and 1 is less than 1, then naturally W will be greater than C, and this result give us the chance to think about the velocity greater than the velocity of light. This result gives us the chance to think about that the velocity may be greater than the velocity of light. Is it possible or not? We have to search about it. This is for later result, later to discuss. But these are the consequences of the relativistic composition of velocities. Now we will discuss consequences of Lorentz transformations. Consequences of Lorentz transformation. Consequences of Lorentz transformation. Mainly three different consequences of Lorentz transformation. One is Lorentz Fitzgerald contraction hypothesis, FITZ GERALD. Contraction hypothesis. Second one, time dilation. Time dilation. And third is simultaneity. Third is let us discuss these three concepts. Lorentz Fitzgerald contraction hypothesis means a rod is moving with respect to one frame. Say this is a frame. Observer in this frame is observing a frame moving along x-axis whose length is L. Its coordinates are x1 and x2, say. So x2 minus x1 will be equal to L. Now the same frame, length of the same frame in second frame, say this is your S frame and this is your S dash frame. With S dash is moving relative to S with velocity v, then what happens? That its length, say it is L dash. Length is L dash. Then what is the relation between L and L dash? How can we find the relation between L and L dash? In this frame, its coordinate, its position is x1 dash. Y and z positions are the same since we are taking this frame along with the x-axis only, parallel to x-axis and x dash axis. So y and z coordinate for the entire length road will be the same, and time of measuring this event, this road at times t1 and t2 at the same time. So the time for this frame S is say t1 and this is t2, and in second frame it is t1 dash and t2 dash. These are the time coordinates for these 2 points or 2 events to end of the road. So what is the relation between these two times? Times will be same. The inverse relation. We are using here inverse relation. So x1 inverse Lorentzian transformation. So x1 will be equal to x1 dash plus vt dash vt dash in 4 second under root 1 minus v square upon c square. We are using, this is the inverse Lorentzian transformation. So x1 is equal to this one and x2 will be equal to x2 dash plus v. V is the relative velocity of second frame with respect to first one. So v t dash, time is the same. In second coordinate is time of measuring this event will be t dash and t dash. At the same time, its location is x1 dash and x2 dash, and in first frame is t and t. So t1 is equal to t2. At the same time, we are measuring the length of the rod. So this will give us this result under root 1 minus v square on c square. Now, what is x2 minus x1? From these two, we will get x2 minus x1 will be x2 dash minus x1 dash upon under root 1 minus v square on c square. Since time measurement is the same, so this cancels out and finally we will get this result. So this is L is equal to L dash upon 1 minus v square upon c square. Now, this factor is less than v is the relative velocity of second frame with respect to first, and it is v square upon c square. Means if it is something, it has some value, then naturally this under root value of this factor will be less than 1. And from here, we can conclude that L is less than L dash. Divided by a factor less than 1 will give us the increased factor. So we conclude from here that L is less than L dash. Means the length of the rod in first frame is L. Then naturally the rod is moving. The measurement of the rod in second frame will be L dash, and naturally this L dash is less than L is greater than L dash is greater than L dash is less than L. L is greater than from this factor. We can conclude that L is greater than, since it has a value less than 1 and divided 1 is divided by value less than 1 give us this result, right? This result L is greater than L dash. So in first frame, length of the rod in first frame is L, and in second frame it is L dash. We clearly see that the length of the rod measured by an observer in second frame, which is moving relative to the first one, is always less. Means it appears that a moving rod or a observer in second frame, which is moving relative to first one with velocity v, is always less. Means it appears a contraction in length appears. Contraction in length appears. So this phenomena was studied by Laurent and Fitzgerald, and they find that the moving rod is always appears to be less. Length of a moving rod is always appears to be less than in first frame. Always less. Now, the time dilation. Now for the time dilation, what means time is appearing dilated in these two frames. A event happens at this point. two events continuously are happening in these two frames are say it is x1 0 0, the coordinate of this point with respect to the first frame, and at the same point two events are happening at the time t and t and t1 or t1 or t2 rather to say. So t1 dash T1 by Lorentzian transformation we know T1 dash is equal to T1 minus Vx upon Vx1 upon C square, Vx1 upon C square upon under root 1 minus V square upon C square. T1 dash is equal to this one, T1 minus Vx1 upon C square, and T2 dash will be equal to T2 minus Vx at the same point. So Vx1 upon C square upon under root 1 minus V square upon C square. Now from these two results we can calculate T2 dash minus T1 dash will be equal to T2 minus T1 upon under root 1 minus V square upon C square, and the second factor will cancel out since it is Vx at the same, we are measuring the event at this same point in two different times, so we are getting this one. So this is delta T dash, I can say delta T dash means interval of time and interval of happening the two events at the same point will be, in second frame will be del T dash, and in first frame it is del T upon under root 1 minus V square upon C square. And from here again the same factor which is less than 1. So from here we find that del T dash is greater than del T, means observer in first frame observing the two events at that point, it always appears to be less than the time noted by the second observer in second frame is greater than. So it appears that the time is dilated, and this is proved by, this is also proved by the experiment of decay of pi Meson. This experimental fact, this is the theoretical result. Time is dilated when moving in observing in a moving frame. So time appears to be dilated, or this fact can be verified from the decay of pi Meson in an experiment. So this I can say a moving clock is always appears to go slow. A moving of time dilated means a moving clock always appears to go slow. This is the second result. This is known as time. So moving clock always appears to be less length, and a moving clock always appears to go slow. These are the two results. Now, simultaneously, though we have discussed this phenomena earlier in our experimental thought experiment, but today, from Lorentzian concept of this, we should discuss this simultaneously. Simultaneously means two events appear at the same time are known as the simultaneity. Now today we are going to decide whether the simultaneity is an absolute phenomena or it is a relative phenomena. Simultaneity means two events. Suppose one event is happening at this time and second event is happening at this time. So in first frame we are talking about these two events in first frame. What happens? So let us suppose x1, y1 and z1 be the time in first frame, and x1 is not equal to x2. x1, y1, z1 and t1 is the time measured by this observer situated in first frame is for this point, this event. Rather to, since we are using t1, so rather to say it is event at this point and event at this point having the coordinates x, x2 and y2 and z2 and t2. Now T1 and T2 are equal since these two events are happening at the same time, and Y1 since these two events are at a different point parallel to x-axis, so Y1 and Y2 are nothing, no difference in Y1 and Z1. The Y1 and Z1 are same for these two events and happening parallel to x-axis. Now, x1 is not equal to x2, x1 is not equal to x2. The same events observed by the second observer in O dash, in second frame, observer situated O dash will be x1 dash and t1 dash. The remaining are same. Location wise, y1 dash and z1 dash, and this event at this point will be observed by this s dash observer situated O dash will be x2 dash and y2 dash and z2 dash are equal and t2 dash. Now t1 dash and t2 dash. What is the relation between T1 and T2 dash? Let us say T1 dash will be equal to T1 minus Vx upon C square Vx1. T1 dash is equal to T1 and Vx1 upon C square upon under root 1 minus V square upon C square, and T2 dash will be equal to T2, T1 and T2 minus Vx2 upon C square upon under root 1 minus V square upon C square. This gives us T2 dash minus T1 dash will be equal to T1 minus T2, since these two are equal, since the event happening at this point observed by this observer situated in first frame observed at the same time, so T1 and T2 are equal, therefore the difference of T1 and T2 is 0 and T2, we are taking T2 and this is minus Vx2 upon C square and minus of this is plus Vx1 upon C square upon under root 1 minus V square upon C square, and this gives us V by C square is common, V by C square common, x1 minus x2 upon under root 1 minus V square upon C square. Now, del T dash, del T means these two events are happening at the same time, therefore del T in first frame is 0, and from here we can find del T dash is something positive. So this factor shows that the simultaneity in first frame is no more simultaneity in second frame. Therefore, we can conclude that the simultaneity is not a absolute phenomena but is a relative one. Thank you to all.